I firmly believe that collaborations with industry are crucial for bringing ideas into the clinics. For the Armin device, we have completed the technology transfer from ETH to Ocoma. The transfer includes the mechanics, the electronics and software, and licenses for the 2 Armin patents. For the Zero-G device, I collaborate with the US startup company Artech in Maryland. This collaboration is mainly based on a common SBIR grant, which is the equivalent funding instrument to Swiss KTI-CTI grants. So now, what do I plan to do with the elderly? The goal of my research is to help elderly persons in successful aging. My general research approach is to study age-related modifications, to derive innovative science-based trainings and intervention to slow age-related modifications, and to develop technical devices to assist or train the elderly people. I will present you 2 possible research directions. Both are centered around mobility and safety. This elderly lady is afraid of falling. Now, please recall the balance and gait training that Kathy Brady was doing with the stroke patient in Zero-G. And ask yourself whether you think that this elderly lady could benefit from a similar balance training. And even more important, can this training prevent her from future falls? These questions are of huge relevance, since falls in the elderly are a major problem. It is estimated that every year 30 to 50% of the population aged 65 and over experience falls, often with severe consequences. So I plan to study laboratory-induced falls of elderly test persons with the goal to derive subject-specific fall prevention trainings. And I will develop devices to train or assist the elderly, like, for example, an artificial vestibular sense. So I will bring elderly test persons into my lab. We will connect this patient or this person to a safety system like the Zero-G, and we will add challenging surfaces, obstacle, attention draining tasks and perturbation forces. We can use virtual reality technology to control the vision of hearing. We measure forces, kinematic data and EMG. By modifying the environment that we present to the test person, we can differentiate and quantify the 3 sensory sources, which mean that we can separate the influence of the somatosensory, visual and vestibular senses. This will allow us to analyze and compare successful attempts to keep balance with non-successful attempts. And we will try to find predictors for falls. And we will look for modifiable parameters. A second possible research direction is to assess and improve driving skills. Here the goal is to find methods to separate and quantify the visual, motor and cognitive deficits, to find predictors and science-based tests for driving ability, and to derive subject-specific training protocols. I have not worked in driving yet. However, there are many similarities to the work that I was doing before. So look at this driving simulator that is used in my hospital. And you can see that also in driving and driving simulation, there are the 3 components: haptics, vision and sound. Therefore, we can use similar engineering technology that we already have been using with the Armin robots. In such a setup, we can measure the interaction forces, the motion, the scalp EEG and other parameters. If required, we could even use MRI-compatible technology and move this setup into the MR scanner to measure functional MRI. One goal here could be to develop a test and training setup that first assesses the patient. One goal could be to develop a test and training setup that first assesses the driving ability of the person and then delivers a subject-specific training protocol that is based on this pre-assessment. I'm very interested in start working in that field. A possible setting for me in Bern could look as follows. I would like to collaborate with the Division of Old Age Psychiatry and with Cognitive and Restorative Neurology. I will try to take advantage of the expertises of Professors Kowal and Steiger when it comes to vision and hearing. And I also see possible overlaps with the work that Professor Weber is doing. Furthermore, I plan on keep working with existing partners and try to find new partners as well. Industry is very interested in elderly technology since the user group is huge. 3 weeks ago, Colombo, Haider and myself had a meeting at the National Rehabilitation Hospital in Washington where we also discussed the possibility about me joining University of Bern, and they are both very interested in a continuation of the collaboration. My current funding from the Hans Eckerberger Foundation and from the National Institute of Health could be transferred to Bern, and I will apply for additional funding from various sources. I will collaborate with existing partners, other academic institutions, and I will try to find new ones. So let me summarize. I studied electrical engineering at ETH Lausanne. Then I joined Robert Riener and Volker Dietz's lab at Balgrist University Hospital and ETH Zurich. As a PhD student, I developed the Armin 1, 2 and 3 devices. I not only developed them, but I also did a lot of clinical evaluation in stroke. Then I moved to Washington. I was on a postdoctoral fellowship that was funded from the Swiss National Science Foundation. And then I became assistant professor at Catholic University of America and at the National Rehabilitation Hospital, both in Washington, D.C. Becoming assistant professor at Catholic University was an excellent opportunity for me to collect experience and to get immersed into the American academic environment. It allowed me to start my independent research activities, to acquire grant money, to set up my lab, to hire my own PhD students and postdocs, and to get involved in departmental service. It also includes teaching. My current teaching assignments include biomechanics, controls, and engineering design methodology. Since Catholic University is a tuition-driven university, teaching is an important part of my tenure package. That is also the reason why the university constantly monitors and evaluates the professors. I like teaching a lot and I'm very motivated to teach at the University of Bern. My money comes from the Department of Defense, from the Hans Eckerberger Foundation, from the National Institute of Health and from the Swiss National Science Foundation. I would like to thank these people for their contribution to this work, and I would like to thank you for your kind attention.